Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. A certain number of candies were bought such that they could be distributed equally among 6, 9, or 12 children. How many candies were bought? And then two statements are given. So the first one is, if there were 18 more candies, they could have been distributed equally among 10 children. And the second statement is, the number of candies were less than 100. And this question belongs to the category of data sufficiency evaluation that's asked in standardized tests like GMAT. And what we have to basically find out in this problem is whether each of the statements by itself or together are sufficient to be able to specify the answer that's being sought, which is, in this case, how many candies were bought. So the way to tackle these problems is, first try putting together the information that's given even before the two statements. So in this case, we are specified, or we are given that a certain number of candies were bought so that they could be distributed equally among 6, 9, or 12 children. And what that essentially means is the number of candies must be a multiple of 6, 9, and 12. From this step, we can basically seek to determine what is the least common multiple of 6, 9, and 12. And this is a pretty simple exercise because these numbers are very elementary. But just to refresh how to find the LCM, what we do is we decompose each of those integers into their prime factors. So 6 is 2 multiplied by 3, 9 is 3 multiplied by 3, and then 12, it will be basically 2 multiplied by 2 multiplied by 3. And then we start including each prime factor. So we start with 6. So we include 2 and 3. For 9, we have 2 3s. Now we don't want to repeat a factor that has been already included. But in this case, we just take 1 3 because we have already included a 3 while considering the prime factors of 6, right? And then for 12, we have 2 2s, but we have already included a 2. So we just take 1 2 out of those 2, and we ignore the 3 because we already included 2 3s before. So the least common multiple of 6, 9, 12, or the LCM of 6, 9, and 12 will be simply the product of those factors that we have circled out, which is 2 multiplied by 3 multiplied by 3 multiplied by 2, and that comes to 36. Now, the number of candies bought is not necessarily 36, but it could be a multiple of 36, right? So we can express the number of candies bought as 36n, where n is a positive integer, 1 or greater than 1, right? So now we consider the two statements one by one. So the first statement basically states that if there are 13 more candies, so if I add 18 to 36, so if there are 18 more candies, they could have been distributed equally among 10 children. So we add 18 to 36n, so 36n is our number of candies, right? And that should be a multiple of 10, so we can write that as being equal to 10k, where again k is a positive integer. So 36n plus 18 should take the form of 10k, where k is a positive integer, so it should be a multiple of 10. And this, of course, from the very look of it, it doesn't really specify n, because there are essentially two variables here, right? N and k. And we know that n and k both have to be positive integers, but it still doesn't specify uniquely the value of n. So it doesn't uniquely specify the value or the number of candies, right? And just to verify that, if you, for example, substitute n equal to 2, you get 36n plus 8 is equal to 90, which is a multiple of 10, right? And if you put n equal to 7, you get 36n plus 18 equal to 270, which is also a multiple of 10. And there are, many more values of n for which 36n plus 18 will be a multiple of 10, but it is enough at this point to be able to conclude that this by itself does not uniquely specify n or uniquely specify the number of candies, because the number of candies is 36n. So we are indeed looking for a unique value of n to be able to determine a unique number for the number of candies, right? So now let's look at statement 2. So statement 2 states that the number of candies were less than 100. So 36n is less than 100. And again, if you substitute n equal to 1, then the number of candies is 36, right? Remember, the number of candies is not n, it's 36n. So we know that n is a positive integer, and so we are substituting positive integer values of n to determine what the number of candies might be, which is 36n. So for n equal to 1, 36n is 36. For n equal to 2, 36n is 72, and that's still less than 100. It's only for n equal to 3 that 36n exceeds 100, and this is clearly not allowed, because the total number of candies, 36n, should be less than 100, right, as per statement 2. But statement 2 by itself, it narrows down the value of the number of candies, right? But it doesn't still uniquely specify what the number of candies would be, because we at least see two options here, like n equal to 1, for which number of candies may be 36, or n equal to 2, for which the number of candies may be 72. So what if we now consider 1 and 2 together? So just to refresh quickly, so 1 was basically, the statement 1 was basically, it was stating that 36n plus 18, so if we add 18 more candies, then that could be equally distributed among 10 children. So 36n plus 18 must be a multiple of 10. So now we check for n equal to 1, what's the value of 36n plus 18? It comes out to be 54. And that's clearly not a multiple of 10, right? But for n equal to 2, 36n plus 18 comes out to be 90, which happens to be a multiple of 10. So this is allowed, and this is the only option pretty much that satisfies both the statements 1 and 2. So taking or considering statements 1 and 2 together, we are actually able to uniquely specify the number of candies, which comes to 72. 36n is 72, right? So going through all the options, option A, statement 1 alone is sufficient. It isn't, right? Statement B, or the option B, that's statement 2 alone is sufficient. We saw that's not true, right? But C, that both the statements together are sufficient, but neither statement alone is sufficient. So that seems to be the most appropriate choice in this case. So the correct option would be the option C.